The first of the range exercises is straightforward. Let's start by creating a range of the letters A through to K. Then because we can iterate a range, we can use our each, pass it a block with argument CHR, and puts the character. When we run the code, we'll get letters A through to K. Because this code is so simple, we can use curly braces instead. So we can do it on the one line, and we get the same result. The next part's quite a lot harder. Using a range, write a method to determine if a given float number is between two values. Let's create a method called included. We'll put a question mark on the end because we'd like this to return a true or a false. The first argument will make the range. The second argument will make the number itself. So if the number is within the range, the number must be more than or equal to the range begin. It must also be less than or equal to the range end. So let's test this. Let's see if the range 1.0 up to 10.9 includes the number 5.7. We'd expect this to be true. Let's try it. Indeed, it is true. So why is this method returning true? When we use a Boolean operator, in this case the ampersand, we're actually getting a Boolean result back. That is to say, we're getting a true or a false value back. Let's try the method with another number. We'll use the same range, but this time test it with 13.5. So we would expect the included method this time to return false, which indeed it does. But there's a problem here. What happens if our range is exclusive? Let's test this out. So let's make our range exclusive, so 1.0 up to but not including 10.9, and then test it for 10.9. So in this case, we should actually get false, because 10.9 is not included in the range. Just get rid of this first line here to make it a bit easier to see what's going on, and let's run the code. So we actually get true. But we expected this to be false, and that's because we haven't factored in the exclusivity of the range in our method. To do so, we'll have to make a small change. We can say if the range excludes the end by calling the exclude end method, we actually want a slightly different calculation. We still want to say number more than equal to range begin, but now we actually want to say, is the number also simply less than the range end? If the range is not exclusive, we can use the original code. All right, let's run it again and see what happens. Now we can see that the result is false. Because 10.9 is not inside the exclusive range 1.0 to 10.9, this is an expected result. However, range actually already has a method to give us this capability. It's called cover. So to cheat, we could just simply call range cover number, and we should get the same behavior. Next, to print all multiples of 7 up to 140, we can use a range once again. So let's first work out what multiple of 7 140 will be. It should be 20. So we can do 1 up to 20, do num. Now to print the multiples of 7, we can multiply num each time by 7. Now to print the multiples of 7, we can multiply num each time by 7. And we get all multiples of 7 up to 140. And finally, we need to write a method that returns the intersection of two ranges as a range itself. Or if they don't intersect, we simply return nil. Let's start by creating a method called intersect and passing it two ranges, range 1 and range 2. Now to help us visualize this problem, it's helpful to draw a diagram. Let's represent range 1 and range 2 on a number line. So in this case, we can see that there is no intersection between range 1 and range 2. And to determine this, we want to see if the end of range 1, i.e. here at point 9, is less than the beginning of range 2, here at point 11. Let's start by checking to see if range 1's begin is less than range 2's begin. So this helps us determine the order of the two ranges on the number line. Let's take a look at the diagram here. It's helpful in solving this problem to visualize it on a number line. We can see here range 1 is represented as the range from 3 to 9 and range 2 is from 11 to 16. These are just arbitrary values I've used to help me visualize the problem. So here we can say that range 1's begin is less than range 2. Now the only way that these two ranges in this case will intersect is if range 1's end here at 9 is more than range 2's begin here at 11. Let's check that. So that means they won't intersect if we say range 1 end is less than range 2 begin. So in this case, we can simply return nil. Otherwise, the range that represents the intersection will be the range 2 begin to range 1 end. So if this is not the case, it means the two ranges must intersect. Let's visualize that. So let's say here that range 1 and range 2 do in fact intersect. So this means that range 2's begin value is less than range 1's end value. So we can define the intersection range as being range 2's begin up to range 1's end. So in our code, we can say else range 2 begin up to range 1 end. This will be a new range that represents the intersection of our two ranges. So to complete this exercise, we need to now reverse range 1 and range 2. Let's imagine that range 1 and range 2 have now been reversed. To complete the code, we need to do the opposite in the second half of our if block. So now we can say if range 2 end is less than range 1 begin, then these two ranges will not intersect, so we can return nil. And similarly, if they do intersect, we want to return the range that represents that intersection. So this time it will be range 1 begin to range 2 end. And finally, we can close our if block off with the end. So in the second half of this else, we're essentially doing the same thing, but the two operands range 1 and range 2 are reversed. So we simply have to change the ordering of the tests.